So let's continue on. I'm not going to review what we did up till now because you had a review last class and that was the test. So what I want to do is go into actually applying what we talked about last time. We talked about what is cognitive science and how you do it. I want to do that now, and I want to kill two theoretical birds with one stone. In that, what I want to do is, while modeling to you how you do cognitive science, I want to also discuss a topic that I think is ultimately going to be relevant to, the cognitive science of the meaning, where we're getting a sense of what this meaning is, It's something that creates these orders of connection that we've talked about in the class already. So, what I want to do is give you a plausibility argument. I want to show you many different problems converging to a core construct. Then I want to show you how there's promise that that construct can be naturalized, analyzed, formalized, mechanized. And then I want to begin, and I will not complete it in this class, to show you the elegance of this construct. And these arrows going out, some of them will be of sort of purely cognitive scientific interest, but many of them will have to do with meaning, meaning-making, making of connections, wisdom, self-transcendence, spirituality, the topics that we brought up as we discussed the genealogy of the meaning crisis. So, this is the project, showing a convergence to a central construct that shows promise of being naturalizable, and then shows, also multi-aptness in it being able to being applied to many different domains that are pertinent to the course, some just for cog sci, but most of them having to do with, as I said, the meaning-making, the spirituality, the wisdom, the self-transcendence. So what I want to try and do is show you how... Could somebody close that back door, please? Thank you. What I want to show you is an argument that some of you will be familiar with, either from Cog 250, the Introduction to Cognitive Science, or from some of my publications. So what I think one of the central issues is facing the attempt to naturalize cognition. So what we're trying to do is in cognitive science, we're trying to analyze, formalize, and mechanize cognition. And so there's some candidate ideas of how to do that. But one of the central ones is to focus in on the notion of intelligence as being sort of the central feature of cognition that we want to explain. It's our intelligence that seems to be related to many of those aspects of our existence that we regard as quintessentially human. So it has been a long-standing project to try and understand the nature of intelligence. Now, what's interesting is how we both test this and how we theorize it, because there's quite a bit of consensus around this, that what makes you intelligent is your capacity for being a general problem solver, an ability to solve problems in a wide variety of domains. So what you want to do is try to come up with mechanisms, that do not themselves require intelligence to operate, because that would be circular, but mechanisms that ultimately would explain our capacity for solving problems in many different domains. So, fortunately, there has been a very influential attempt to analyze and formalize what it is to be a general problem solver, as to what it is to be a problem solver. This is the work of Newell and Simon on a thing called the general problem solver. That's what GPS once meant. It doesn't mean that anymore, of course. But that's what the GPS once meant, to be a general problem solver. And so what they did is they provided an analysis of the components of a problem, and then a mathematical formalization. And then in addition, they created the first attempts to mechanize it by creating computational machines that would actually carry out problem solving. So not only were they foundational figures in psychology, the psychology of intelligence, and economics about wide-ranging problem solving, they were also pivotal figures in the foundation of artificial intelligence, the attempt to create machines that are in fact intelligent. So how did they analyze problems? So the analysis, now what I'm going to say initially will sound like sort of like so. Just be patient, because there's a bit of a twist that turns out to be very profound. There's a reason why these guys have got some of the most important premier awards that science gives out. It was actually very foundational work. So they analyzed a problem into 4 key components. So a problem exists when you have a goal state. Suppose you were thirsty. Your goal state is to not be thirsty anymore. And then your initial state is different from your goal state. Okay? So I don't want to be thirsty, and currently I am. So the disparity from my initial state and the goal state is what constitutes a problem for me. Then what I have is I have various operations or actions I can perform that will transform my initial state into some other state. So the initial state is all of my features right here, right now. I can change some of them. For example, I can move to the right. So that changes my initial state. I can lift my arms. That changes my initial state. And so what happens is there are many different operations I can perform that will take me to another state. Okay? So first component is whatever the system is that is going to be solving a problem, it has to have some representation of the initial state. It has to have some representation of the goal state. And then it has to have the ability to identify and apply operations to the initial state and transform it into some other state. Okay? So far, so good, right? And of course, when I get here, I can perform other operations. There I could do that or that. There I could do this or this. Perhaps this one has multiple outcomes, etc. Okay? Now, so far, I've analyzed the problem into 3 things: a representation of the initial state, the goal state, and the application of operators. Okay? There's a 4th component, which is based on the idea that you're a general problem solver and not a specific problem solver. This is the idea that you're not going to solve any one problem in such a way that you will devastate your ability to solve other problems. Okay, so these are called path constraints. And the basic idea behind a path constraint is I don't want to solve one problem that will make it very difficult for me to solve other problems I might be engaged in. So I don't want a problem solution that will, involve me destroying my house, typically. Because if I have to cook my dinner by burning down my house, right, that's not a very good problem solution. It will cook my dinner, but of course it will mean a lot of other problems that I need to be solved will become very difficult to solve. So these are called path constraints. Path constraints are limitations on the kinds of solutions that you're allowed to accept, right? Right. And so on and so forth. Okay, so what's a problem solution? A problem solution is any sequence of operations that will turn the initial state into the goal state while obeying the path constraints. A problem solution is any sequence of operations that will turn the initial state into the goal state while obeying the path constraints. That's a problem solution. Okay? And a problem-solving method is any technique for finding a problem solution. A problem-solving method is any technique for finding a problem solution. So that's, right, the analysis. What you basically have is you have an analysis of intelligence into being a general problem solver, and then you have the analysis of what it is to be a problem solver into these components: initial state, goal state, operations, path constraints. And then you have, right, an analysis of what a problem solution is and what a problem solving method is. Now you can, of course, start to, once this, the other thing they did with this analysis is that it afforded a formalization. And the formalization is where something really key starts to come out. So the problem with this diagram, of course, is that you see it from above. So you could look at all the pathways and see those which go from the initial state to the goal state. The problem facing you is twofold. First of all, many of the pathways dead end. Many of the pathways don't go from the initial state to the goal state. And secondly, in real life, you're here, looking this way. You don't know which of all of these pathways, which ones, or there might only even be one, leads from the initial state to the goal state. You don't know. Right? And the problem with that is the size, the typical size of these search spaces. This is called the search space or the problem space. Okay? So a guy by the name of Keith Holyoake, gave a famous example to make it concrete. So you can calculate the number of pathways by f to the d, where f is the number of operations you can perform at any stage, and d is the number of stages you go through. So Holyoake gives a classic example of a chess game. So at any time, on average, you can do 30 moves. You typically have more options available to you at the beginning and fewer at the end, but on average, there's 30. And there's usually 60 turns to a game of chess. So that's the number of alternative pathways that need to be checked. Now, what do you think about that number? Does anything come to mind? Anything? Do you notice any important property of that number? Yes. It's really big. It's bigger than big, right? So this is known as combinatorial explosion. So this is 4.2 something times 10 to the 88th in standard scientific notation, which is really huge. Now, one way you might respond to this is you might say, well, my brain is really complex. I'm always hearing this on the news about how complex the brain is. It's the most complex thing in the universe, which of course is definitionally false, because your brain plus anything else is more complex than your brain. But you sort of get the idea. It's a very complex thing. And you're right. And you know, these are the number of, right, neurons you have. It's a lot. But it's really dwarfed compared to this number. It's insignificant compared to this number. And you may say, well, it's the number of connections. And that's true. The connections are much higher, 10 to the 15th. But that's still dwarfed by this number. So even if every connection in your brain was being committed to searching every single pathway, each one is studying, right, 10 to the 53rd number of pathways, each synaptic connection. It's still a huge number. Right? In fact, the number of particles in the universe, right, is probably 10 to the 82. So this is bigger. Even the universe would take some time, the whole universe, dedicating each particle to searching a pathway. Okay, I'm trying to convey to you how really, really big this is. Okay? And it quickly became apparent that this is the crucial issue. This limitation. There's no way that with our finite resources, even though our brain is so big, compared to this, it is dwarfed, right? There's no way that we can search all of the available information, all of the available options. Okay? Now this has become something of a consensus view within psychology as well. For example, Keith Stanovich, in a recent book on what intelligence tests miss, in which he talks about both the nature of intelligence and rationality, he argues, right, that what intelligence basically is the capacity to avoid this, to deal with our computational limitations. So part of what it means to be intelligent is this. Out of all of the information you could search, you don't search most of it. You somehow only search a very small fraction of it, and yet you solve your problems. Somehow you zero in on the relevant information, the information that is important and useful to solving your problem. And this is the key thing. Somehow you ignore, you do not even consider all this other information. It sounds like a Zen paradox, right? The way you become intelligent is by ignoring most of the information. But in a sense, that's what you're doing, right? Now, for reasons that'll become clearer later, the work I've done with my colleagues and some of my students have gone on to do work on, I call this process relevance realization. Zeroing in on the relevant information. And making it real, making it causally effective in your cognition. Now what I'm going to keep arguing, just to foreshadow, so I'm going to show you how many different problems within psychology and artificial intelligence converge on this problem, the problem of relevance realization. Some of them I'll go through more thoroughly, some of them I'll just gesture and tell you where you can go and read more about it. Okay. Now Newell and Simon were aware of this. They were very aware of this. In fact, they took this to be one of their central discoveries. Right? And I think that's very important. Because your brain is doing it right now. Of all of the information you could be paying attention to in the room, and all the various connections you could be making to that information, all the information in your long-term memory, and all the various connections you could be making between those pieces of information, and then all the various connections you could be making between your long-term memory and all of the information available in the room, you're somehow zeroing in on a very small subset. And you're doing it right now, and you just did it again. And you just did it again. Now what was intriguing, of course, and this is how we could tell that this was good science, is that until we started to do the cognitive science, we didn't realize that this was the issue. We didn't realize that this was an issue. Now, Newell and Simon had a response to this. They made a distinction between two problem-solving methods. And I'm going to use the way they use the terms, not necessarily how they are used right now within computer science, but this is how the terms were originally used, especially by Polya and others. They made a distinction between an algorithm and a heuristic. An algorithm is a problem-solving method that is guaranteed to find you a solution or prove that no solution is possible. Right? So, there's an algorithm for determining the number of people in this room. The algorithm, I count them. I can do it. If I do the algorithm correctly, it is guaranteed to give me a correct answer. I count the number of people, and then I say there's 27 or whatever. Okay? A heuristic is a problem-solving technique that cannot guarantee to find you a solution, but promises to increase the probability that you will find a solution. Now, we know what some of those are in chess. Get your queen out early, control the center board, castle your king. The thing is, you can do all of those and you can still lose at chess. Those are heuristics. They increase your chance of winning, but they don't guarantee it. The problem with algorithms is, so this is the tricky bit you've got to get, right? In order to guarantee finding a solution, how much of the search space does it have to search? Guarantee that it will absolutely find a solution. How much of the search space does it have to search? Yes? All of it. So almost always, algorithms in this sense of an algorithm will commit you to too large of a search that you can't possibly do because it is way too combinatorially explosive. Yes, Alan?
Is there proof that algorithms must search for the resource space?
Pardon me?
Is there a mathematical proof that an algorithm...
You don't need a mathematical proof. It's a conceptual argument that runs from the definition. Because if you even leave one path open, right, and that could be the path that is the answer. So, what do you do next? Well, what Newell and Simon concluded, and this is part of the answer, but it's not going to be the full answer, is most of your cognition uses these things called heuristics. So what does a heuristic do? What a heuristic does is it tries to pre-specify where you will search. What it does is say, only look at this kind of information. Don't look at these other kinds of information. It tries to pre-specify what information will be relevant. So for example, in the chess heuristics, the heuristics for chess tell you they make the center of the board important. You pay attention to the center of the board and you pay attention to your king. And there's lots of other things you don't focus your attention on. Okay? So they try to pre-specify so what goes into that? Well, that involves a couple of assumptions that certain kinds of information will always turn out to be relevant, and you'll see for reasons we talk about later that's false. Right? Secondly, right, this is trying to deal with combinatorial explosion by limiting what you consider, what you pay attention to. But if the first assumption is sometimes false, if some of what you think, if you try to pre-specify what's going to turn out to be relevant and that turns out to be wrong, then of course the heuristic goes from being something to help you to something that harms you. Because another word for pre-specify, of course, is to prejudge, and another word for prejudge is to prejudice. Heuristics will often bias you. Now, I'm going to stop here and say, even though we're doing this, what many of you are going, I didn't sign up for this in this course. I wanted brain stuff and Buddha stuff. I wanted to know how to sit in a corner and become enlightened by crossing my toes in a certain way, stuff like that. Okay? But what I'm trying to show you is, we're getting into some core stuff, and here we have the beginnings of a really important, I think, idea. Right? The idea that the very processes that are making us intelligent are also making us susceptible to self-deception. Ways in which we bias our attention and what we find salient or relevant such that we can't solve our problems. So we're seeing, this is what the cog-sci is doing. It's showing a deep interconnection between the machinery of intelligence and the machinery of self-deception. And this, I think, is going to be a way of understanding one of the central Buddhist claims, right? The first noble truth, which is very poorly translated, we've talked about this before, as all is suffering. A better way of thinking about it is that a better way of translating might be something like, everything is vulnerable to self-deception. There's no part of your experience in which self-deception might not be at work. Okay? That's because all of your experience, almost all of the time, is doing relevance realization, and heuristics are at work. And where heuristics are at work, there's the potential for bias. So let's go over this again, right? So a couple of things you do, there's many of these biases that have been studied by people like Kahneman, Tversky, Stanovich, and others. Let me remind you of a couple of heuristics that we have very good evidence that people reliably use. Okay? So when you're trying to figure out the probability of events, if you were to try and do it algorithmically, if you would try to use formal probability theory and calculate all of the variables, you would very quickly get into combinatorial explosion. So typically, you don't do that in real situations. You use a couple of heuristics to try and help you estimate the probability of things. So one is the availability heuristic. And the availability heuristic goes like this. The more easily you can remember or imagine an event, the more probable it is. Okay? So the more easy, so what you're doing is you're not doing all the calculations because it would be combinatorially explosive. You're zeroing in on some key features. How easily can you remember it? How easily can you imagine it? And then you're using that in order to judge the probability of the event. The other one is the representativeness heuristic. This is sort of how salient the event is to you, how much it sort of stands out in your mind, how much it sort of arouses you, your attention and your emotion, how representative it is. Okay, so let me give you a prototypical example. and the funny thing is I know this and I lecture on it, and yet it still happened to me. I found myself doing it, and I'm sort of watching myself do it. Okay, so my girlfriend was flying down to the States a few weeks ago to attend a wedding, right? So she's getting on an airplane. So airplane disasters are really salient because when they happen, like everybody gets all upset and the news and it's ghastly imaging, right? And then availability. How easy can I imagine a plane crash? Very easily. I've seen lots of movies. Can I remember them? Oh yes, I've seen lots of. So I can easily imagine them and remember them. And then I got this representative. So she's going and I'm saying, please be careful. Oh, please be careful. What I'm doing, you know, Bronze Age magic. I'm basically saying, don't die, please don't die, please don't die, right? So I'm doing that. I'm saying, be careful, text me when you're there so I know you're safe and everything, right? And everything. And we do this when we take our loved ones to the airport. And then after they go through the gate and we see them no more, we turn and without a second thought, we go back to our car, which is North America's death machine. Kills more people than handguns, more people than heart attack. And yet you don't pay attention to it. Okay? So that's an example of how the heuristic, right, processing you, right, can bias. So there's a formal proof of this. It's called the no free lunch theorem. I kid you not. That's what it's called, the no free lunch theorem. And it basically says, so this is how well it helps you solve a problem. These are the x-axis are problem types. And for any heuristic, it has this function. There's a set of problems that it will improve your performance, but the price you pay is that there's another set for which it will actually make your performance less than average. This is inevitable, any heuristic. And this tells us something. It tells us, and we're going to come back to this, it tells us that this idea that we can pre-specify what's relevant is fundamentally wrong. We can only do it in a limited fashion for which we pay an inevitable cost. Okay. So, that's sort of as far as Newell and Simon got. And what they did was they did, and I won't go into it in detail, they do it more in Cog 250, they did an analysis of sort of kinds of heuristics, and they tried to come up with the best heuristic. But ultimately, they were not capable of producing the general problem solver. And many people, myself included, have come to the conclusion that that's because, right, although heuristics are probably a necessary component of what makes you intelligent, it's not sufficient. There's something else going on. And to get at what was going on, we have to look at some assumptions that Newell and Simon made. So right now, notice what's happening here. We're doing some psychology, but we're also doing this, sort of attempt to analyze, formalize, and mechanize, right? I'm bringing in psychological data, like the representative heuristic, the availability heuristic. But we're talking about sort of basic machine learning ideas. And now I'm going to make a philosophical move. Do you see how all the different components we talked about in CogSci are coming together here? Right? What's the philosophical move? What philosophers are very good at, right? All right, is getting at people's assumptions and presuppositions. Philosophers are like, I know many of you probably find philosophers frustrating because it looks like all they want to do is keep with their questions and never get the answer. Just give me, what's the answer? Is there a God or not? Come on, right? But philosophers are generally much more interested in how the questions have been posed. What are the assumptions? What are the presuppositions? And we're going to see that at work a couple times here. Like, philosophy isn't about sitting around in cafes saying vaguely obscure things in a French accent. Like, it is not the nothingness of being, it is the being of nothingness, or stuff like that. That's not what it's about. It's about trying to afford a deeper understanding by removing ways in which we have malframed our questions. Kind of like what philosophy does is help us realize that we're inside some box that we've imposed on some 9 dots and how we get out of it. So what was going on here? What was the assumption? Well, Newell and Simon made a very critical assumption. They assumed that because we had this single word, problem, that all the things that it applied to were in some sense essentially the same. This is the notion of essentialism. That because we have a name for something, all of the members of it must share an essence. All of the members must share a set of necessary and sufficient conditions. They're all essentially the same. So all dogs are essentially the same. All triangles are essentially the same. Now, I can't go into this in great detail. You can go take Cog 250. That idea turns out to be pretty much false. There are some concepts that seem to have essences, but very, very many of them don't. So you remember William of Ockham? Remember how he said there aren't these essential properties? Much later, somebody influenced by that way of thinking, Wittgenstein, pointed that out. We talked about this briefly, but let's come back to it. So how many of you have played a game before in your life? Raise your hand. How many of you have played more than one game in your life? Raise your hand. Okay. How many of you have played many kinds of games? How many of you, if I asked you, could you go into that house and find me a game? Do you think you could do it? How many put up your hand? Yes. Okay, so this is not a bizarre thing. This isn't like subatomic quark spin or something like that. This is like, yeah, a game. Do you want to play a game? You can say that to your kid, and they'll go, yeah. They won't go, what do you mean? Okay? So, if essentialism is right, you should be able to give me the essence of a game, which means you should be able to give me a definition that will include all and only games. It will exclude nothing that is a game, and it will include nothing that is a game. Anybody want to try? Many of you are now terrified because you're familiar enough with me. Right. No, he's gonna do something and show me that I've always hated my brother. Okay, so you might try some things like it inherently involves human competition, and then I'd say, well, what about catch? We have to play against other people, solitaire. Well, it has to involve imagination, tag, right? It's always done only for fun. Some people take chess as a game very, very seriously. You wanted to try?
Yeah, sure. There's winning and losing, and there's rules.
Okay, so are there other things that have winning and losing and rules? Like law? Court? Is court a game? So you've included something that doesn't belong, so you failed. You can only include things that are games, and you can't include things that aren't games. Yes, Alan?
Interactive entertainment.
There's lots of interactive entertainment that aren't games, right? Well, is a conversation a game? You don't think so generally, right? Yet conversation seems to be interactive entertainment for many people. Anyways, don't do this, because this has been around since the 50s and nobody has been able to come up with a counterexample to Wittgenstein. In fact, Jerry Fodor has a bunch of papers showing that this happens for almost most of the concepts you use in everyday life, like game, chair, table, paint. He has this long essay, how you can't give a definition of to paint something. And you may think, well, it's to put paint on things. No, it's not, because if I drop paint on the floor, I haven't painted the floor. Well, it's to do it intentionally. If I throw the paint on the floor in anger, have I painted the floor? No. And then he goes on, and you just, and you give up, right? And that's the point. Okay, now why did I show you this? I showed you this because Newell and Simon were falling prey to that. They were thinking that because we have this term problem, that all problems are essentially the same, that there's an essence to problems. But that, as we'll see, probably doesn't turn out to be deeply correct. Now, instead, right, what would happen if you challenge that? What would that mean to challenge that assumption? Well, first of all, something that you might have initially thought that was trivial would turn out to not be trivial. Many people have different words for this. This is the one I prefer. Problem formulation. Problem formulation is generating that representation of the initial state, the goal state, the operators, and the path constraints that sets your problem up. That's problem formulation. Bless you. Now, if you think all problems are essentially the same, then this becomes a trivial thing, because you're going to essentially set up every problem in the same way. There's going to be variation, but the essence is going to be the same. But if problems don't share that kind of fundamental essence, then problem formulation is going to turn out to be very, very crucial. Problem formulation is going to turn out to be very, very crucial. And let me show you an example from another psych experiment of exactly this, and it will also allow me to introduce another topic from a cognitive science perspective that we've been talking about in this course already. So I'm going to take this off. Right now we're doing this, right? And then we're going to do this, and then we're going to start doing this, and it's going to be this for the rest of the course, right? So the whole course has one big argument, made up of little arguments, made up of smaller arguments. Okay? So this is from a study done by Kaplan and Simon in 1990, a bunch of experiments. This is the same Simon from Newell and Simon, by the way. This was done in 1990. So they ran an experiment on people trying to solve a problem called the mutilated chessboard. The mutilated chessboard. Okay? Which sounds like the name of a very non-scary horror movie. Okay? Oh no, it's the mutilated chessboard. Okay. So, how many, you may not know this, but you've all seen this entity. None of you are going, oh, what is that strange ceremonial object? Okay, so how many rows are there? Sorry, how many rows are there? Do you know? There's 8. And because it's a square, you can now tell me how many columns there are. 8. You're all looking at me again like, you did that 9-dot thing on me. Okay, so how many little squares are there? Come on, you could do this in grade 6. How many little squares are there? 64. 8 times 8 is 64. Okay. Now, if I have a domino and it covers 2 squares, and because it's a square, it can cover 2 squares vertically or horizontally, right? How many dominoes do I need to cover the chessboard without overhang or overlap? 32, which is the correct answer. So far you're wondering, yes? Okay, now what I'm going to do is the following. I'm going to mutilate the chessboard, hence the name. I'm going to take away this square, and I'm going to take away this square. Okay, so now there's 62 squares left, correct? The mutilated chessboard has 62 left. Can I cover it without overhang or overlap with 31 dominoes and prove that your answer is correct? Can you prove it? Okay, you have to be able to prove it. Pardon me? I can't quite hear you. But why can't I just go this way and then have a domino there to cover off the thing, and then go that way, along there? Because I can interspace with vertical and horizontal. Okay, so many of you are staring at the board and your eyes are moving to the left, which means you're trying to imagine it. Okay, so we know this because we've run this experiment quite a few times. It's been replicated a lot, by the way, which is good for psychology right now. Right? So many of you have formulated this as a covering problem. What you're doing is imagining the chessboard, and then you're trying to imagine various configurations of dominoes to see if you can make a configuration that will fit this. Okay? You've set it up as a covering problem. If you set it up as a covering problem, it is combinatorially explosive. In this experiment, one of the participants filled, I think it was 63 pages of a Hilroy notebook, mathematically trying to calculate it once he had formulated it as a covering problem. It's combinatorially explosive. You can't do it. It will take you too long. So if you formulate it in a way that your brain sort of standardly tells you to do it, this problem becomes not theoretically impossible, but practically impossible. It would take you too long to do it, even if you have the requisite math skills. Okay, let's try reformulating the problem. Reformulating the problem. Okay. So this isn't obvious. No, so there's one way in which my diagram is misleading you, but it doesn't matter because in the experiment you had actual diagrams of chessboards. Okay? So although you may think this is a confounding variable, it turns out it isn't. But I'll just tell you a relevant factor when it comes. Now when I put a domino on the board, either horizontally or vertically, it has to cover a black and a white square. Yes? Is there any way of putting it on the board which will not cover a black and a white square? No. No matter how I do it, it's going to cover a black and white square. Okay, which means in order to cover the board with dominoes, I need an equal number of black and white squares. Yes? I must have an equal number of black and white squares. Okay, so I must have, it is necessary that I have an equal number of black and white squares. But if you pay attention, and you can see it in the diagram, these two squares are always the same color. They're always the same color. That's just how it turns out. They're always the same color. So if I take them away, do I have an equal number of black and white squares here? But I must have an equal number of black and white squares. I don't have an equal number of black and white squares. Therefore, it's impossible to cover it with 31 dominoes. Because something that I must have, it necessarily does not have. So in 3 steps, I can prove to you you can't do it. Now notice what happened. If I try and formulate the problem as covering, I go, ooh. I get lost in combinatorial explosion. I'm not zeroing in on the relevant information. And I think shape is the relevant information, like configuration. But if I reformulate it, I zero in on the relevant information, and I get my answer. That's the power of problem formulation. Problem formulation sets the problem up so that when you apply your heuristic thinking, it connects to the relevant information. You're not in combinatorial explosion, you're not biased, but you're zeroing in on the relevant information. That's the power of problem formulation. And this is something that Newell and Simon missed. This is, by the way, why philosophy is important. Because how you formulate your problems has a huge impact on how you're going to be able to solve them or not. And sometimes we get very impatient with philosophers. They take centuries to do things. Just collect the data, just solve the damn problem. If it's formulated improperly, rushing to the data or rushing to solve the problem now might actually be a colossal waste of time because you have misformulated the problem. Now, what might this phenomena be? Does this remind you of anything? This is similar to another problem I showed you in the class. What does this feel like in some ways? Anybody? This is kind of like the 9-dot problem, right? It's one of those problems. Now, I'll tell you the title of the experiment. It was called In Search of Insight. Because what this is showing you is what's going on in insight. Insight is when you replace an inappropriate problem formulation with an appropriate problem formulation, where you replace a bad problem formulation with a good one. Now, there's 2 ways in which your problem formulation can be bad. One is, in the 9-dot problem, you can be biased against the information you need. That's what goes wrong here. That's this biasing issue. But a poor problem formulation can also, right, keep you in combinatorial explosion rather than getting you to a problem solution. So problem formulation, right, is really important. Insight is when you change a poor problem formulation for a good one. Now here's a very, very interesting thing. There were people in this experiment that came up with the solution spontaneously. They figured out the answer. They were able to do it. It's hard, but it's not like the 9-dot problem where most people don't get it. Right? Now, one of the things that tells us is that one of the things your relevance realization machinery can do, and think about the course now, think about the course, is it can step back and look at its own problem formulation. One of the things your relevance realization machinery can find relevant is how you've been trying to formulate your problems. One of the things that your relevance machinery can find relevant is your very attempts to find relevance. It's that stepping back and looking at that we were talking about that allows you to transform how you're framing, how you're setting up your problems. Now that points to something else about problem formulation. And it goes to the second flawed assumption in Newell and Simon's work. Newell and Simon thought that all problems were sort of fundamentally the same. There aren't any important differences between them. And that leads to this issue, right? It's probably not the case. There probably seems to be some important differences. The one I want to concentrate on for us now is the difference between well-defined and ill-defined problems. A well-defined problem is a problem whose problem formulation is good enough that you can apply your heuristics to it with a reasonable chance of solving the problem. In fact, some problems can be so well formulated that you can apply algorithms to them and solve them. So I take it that for many of you, this is a well-defined problem. And what do I mean by that? You know what the initial state is. And knowing what the initial state is informative. It gives you guiding information. What kind of problem is this? Can anybody tell me? It's a multiplication problem. Again, I assume you can do this. I didn't even put 2 digits down here. Just 1. Okay, so you all, and you immediately are limited to the kinds of operations you can perform. You can do something from the multiplication table. You can do addition, right? You can do transposing the little number to keep your place. The number of operations is very limited for you. Set out. There's lots of stuff that you just won't think to do. Singing doesn't help. Dancing doesn't help. Changing the color of the numbers doesn't help. Okay? You also know what the goal state should look like. What should be here when I'm done? Another number. Right? So a drawing of a platypus, a map of the ancient Egyptian empire, none of these things would count. Even if it's the beautiful, that's the best map of the ancient Egyptian empire I've ever seen in my life. Doesn't matter. Okay? You can also tell me, is this number going to be bigger or smaller than those numbers? Okay, bigger because this isn't a decimal again. All right, I know you're saying, I took this course because I didn't want to go into math. Okay, so that's a well-defined problem for you. All right? Now, an ill-defined problem is one in which the representation of the initial state and or the goal state and or the operators and or the path constraints is very unclear to you, missing, murky. Okay, so Thomas, all of you, I'm just pointing to Thomas because he always brings so many writing implements, which I find fascinating. Right? Thomas is trying to solve an ill-defined problem right now. Just to remind you, remember who's he writing to? Thomas, which is kind of creepy. Okay, so it's distributed cognition, we talked about that. But Thomas is facing this ill-defined problem. He needs to take good notes. Okay, so what's the initial state? I don't have good notes, blank page. Is that very helpful? Does that give you a lot of guidance as to what to do? No. There's lots of things that start with a blank page. Okay? What's the goal state? Having good notes. And what are the features of good notes? And without using synonyms for important or relevant, or, right? What kind of information, like key or crucial or central? What should be in your notes? How should you format it? What future Thomases should he care about? Should he care about Thomas, on Friday night, who's a little bit drunk and has been really listening to a lot of Led Zepp or something, and these notes don't make any sense to him? Do you care about that right now? Probably not. Right? What are the operators? Well, write stuff down. Good. Good. Which stuff? Everything I say? That's not a good plan. Because, right, you're given the ill-defined task of not parroting what I say, but showing me in your own words that you understand it. So you have to somehow translate what I'm saying into stuff that makes sense to you so that you can demonstrate later back to me that you have understanding. Look at all the things that Thomas does. Can I hold this up? Is that? Look at all this. It's wonderful, eh? Color coding and diagrams and big R. I think this is relevance realization, right? Apparently it's orange, right? So he writes stuff down, he draws pictures, he puts some color into some things, he uses spacing. Zhaifeng does different things. He does, some of the same diagrams, different words, not much color coding. He's not into that, right? But he uses a little bit more arrows and indentation. He uses more of this page too, right? So he likes to spread out. He's very imperialistic in his note-taking, right? Okay, so I'm trying to show you that although there will be some similarities between them, there's going to be huge differences because they're trying to solve this ill-defined problem in a way that is going to work for them. Now here's the thing. Most of life's real problems are ill-defined problems. Okay? So, following a conversation, okay, right? Well, you listen to other people, yes. Well, what do you listen to? Well, I try to pay attention to what they're saying. Every single thing? And they won't say everything that they're meaning, will they? No. Like, I have to try and figure out what they're saying and what they're implying, and we'll come back to this later. All right? And what do you do? Well, I say stuff. When? Well, like when there's, an appropriate time to do so. And you use the word appropriate or relevant. I say the relevant thing at the relevant time to the relevant purpose, which is all ways of saying it's very ill-defined. I have to use my ability to zero in on what's relevant. Right? The prototypical example I use of an ill-defined problem is the one that has occurred to me sort of 3 crucial periods in my life. And this is going on a successful first date. You know it's an ill-defined problem because your friends give you the most useless advice ever. They will say things like, so I'm straight, so this is what they would say to me. They'd say, well, look at her, but not too much. Right? Smile at her, but not too much. Ask questions, but not too many. Give her time to talk, but don't do it too long. So it's like, and then I realized the only function of this advice is that, so if I succeeded in the date, they could say, see, wasn't I right? And if I failed, they could say, see, wasn't I right? That was the main function of the advice. Okay, so ill-defined problems, right? What's missing from an ill-defined problem? What's the first thing you have to do before you can apply your heuristic? What's missing is a good problem formulation. A good problem formulation that helps you fill in and zero in on the missing relevant information. You have to do a lot of relevance realization. I kept pointing that out to you. You kept wanting to use synonyms for relevance to tell me how you dealt with an ill-defined problem. You have to do a lot of relevance realization, right, to create the missing problem formulation. You have to turn an ill-defined into a well-defined problem formulation. Now, one thing that we're not doing enough of in psychology is we're not doing enough studying of that kind of insight, where an ill-defined problem is turned into a well-defined problem. But I think more of that needs to be done. So, what are we seeing here? We're seeing that at the core of intelligence is this capacity for solving problems, right? And at the core of that is problem formulation, and the central issue in problem formulation is the relevance realization that helps you avoid combinatorial explosion and helps you deal with ill-definedness. Relevance realization is at the core. Okay. So I've done work with Leo Ferraro. He's a psychometrist. That's a person who is professionally trained to give IQ tests to people. And one of the things we published, part of an argument we published in 2013 was that almost all of the tests that we give for intelligence are actually tests of a person's ability to zero in on relevant information. You can show that almost all of the various different tests are trying to do that. Now, I invite you to read the article if you wish, but in order to buttress that claim, what I'm going to do is show you some other key things that we sometimes measure when we measure intelligence, and how they also involve relevance realization. So you may be getting some inkling of what I'm going to start arguing. I haven't got anywhere near making this a plausible claim, but the inkling you might be having is that I'm going to argue that relevance realization is actually what we're talking about when we're talking about the meaning making that makes these connections. I'm going to try and show you how it is so fundamental to your cognition that if relevance realization isn't working properly, your very cognitive existence, your cognitive agency is at risk. And that's why you so fundamentally care about meaning in this way. Now, I haven't made that plausible to you yet, but that's what I'm arguing towards. Because I want this to be a well-defined problem in which you have some representation of the goal state. Another thing we measure in psychometric tests, and another thing we think is a sort of fundamental aspect of cognition, is your ability to categorize things, your ability to put things into categories. So some of the IQ tests will be, which category does this belong to, or group these things into a category, etc. There's tests like that. And you worry about this because we on Sesame Street you have this issue where one of these things is not like the other. What is it? 2 of these things are kind of the same, or 3 of these things are kind of the same. And you do this whole little exercise to try and get how categorization works. Why is categorization so important? Because categorization allows you to not have to treat every individual as a raw individual the way Occam said it might be. Like if I know this is a chair, I can transfer all my chair knowledge to it. And that's a chair too. And so is that. Imagine if you had to learn each thing as a raw individual, the way you learn like each person as a raw individual. So, this is Agnes, and this is Peter, and this is Francois, right? And you'd have to do each entity. Can I trust Peter? I don't know about Peter. Peter might lead, maybe. And I can't even say he's like Agnes because then I'm already categorizing. I'm putting them into the same category. Categorization allows you to code the world so that you can avoid a lot of that combinatorial explosion of information. Categorization allows you to make, important conclusions, make important inferences. Because this is a chair, I can draw a whole bunch of conclusions about it, even though I might not have ever seen this particular entity before. Now, they're not certain, they're not deductive conclusions, but they're inductive. If it's a bird, I know a lot about it, even though I've not met this particular bird before. If it's a tiger, I know a lot about it. Imagine if you couldn't make those inductive inferences. The power of your mind, the scope of what it can cognize about is dramatically increased by your capacity for categorization. It really improves your communication because categorization allows you to use common nouns like fire. I can say that, and a lot of different things will fall under that, and yet many of you, will know what to do. If I yell, fire! Right? If I had to describe fire without being able to categorize it in terms of sort of basic perceptual primitives, yellow, orangey, moving, shifting, change. Like, we're all dead by the time okay. Okay? Categorization, that's why we do all these tests for categorization. Okay? That's why we use it as a test for when to see if somebody suffered sort of core brain damage. If categorization starts to break down, we know that something fundamental is going wrong. Right? Here's a shirt and here's some pants. What are they both? They're clothing. But if somebody says, and people often confabulate who have brain damage, right? The top thing takes up so much space, and the bottom thing is flatter, and you're pointing out the difference between wider and narrower things to me. And you go, no. Okay? But remember what they did, by the way, those people who have the brain damage. Okay? If you want to see what happens when that system breaks down, there's a really excellent book by Oliver Sacks called The Man Who Mistook His Wife for a Hat. Because his ability to categorize basic objects had broken down, and so he thought his wife's head was a hat, and he kept trying to put it on, which his wife found distressing. Okay. Now, you may think, okay, well, so what? What's the issue? What I do is I look out, like Sesame Street. You know, three of these things are kind of the same. I notice which ones are similar. I notice which ones are dissimilar. I mentally group the similar ones, and I keep the dissimilar ones apart. What could be more different? Like, that's so easy. That doesn't require any challenge at all. Here's an important rule of thumb. All right? Sesame Street is good for training your abilities. It's not very good for explaining your abilities. Because the language by which we train our skills is very often not the same language by which we explain them. And you shouldn't import that uncritically. Okay? This notion of similarity causing categorization was challenged by a philosopher, Nelson Goodman, which is a great name for a philosopher to have. There's only one better. There was a philosopher his name was John Wisdom. Okay, so what Nelson Goodman pointed out, he said, okay, well, what do you mean by similarity? Well, that's easy. Sesame Street gives us the answer. Kinda the same. And kinda the same means partial identity. They're partially identical. They're not fully identical, they're partially identical. Okay, that's great. What do you mean by partial identity? Oh, well, I mean they share properties, like they're both the same shape. They share properties. There you go. That's easy, right? Well, that means the more properties any two things share, the more similar they are. And that's how we do it. Oh, look, these two things have 8 shared properties. They're very similar. These only have 4, not as similar. I will group these ones together. I will keep these ones apart. The problem, Goodman pointed out, is this. For any two objects, there's an indefinitely large number of properties that they share. For any two objects, there's an indefinitely large number of properties they share. So I take it most of you don't put those two into the same category, a plum and a lawnmower. Just let me make this point. Okay, so let's take a look at, right. So both of these things have an odor. Both of them contain carbon. Both of them are found in North America. Neither one of them existed 300 million years ago. Both weigh more than a paperclip. Both contain the letter M as words in their name. Right? Neither one makes a particularly good weapon. How many properties do you think I can come up with that they share? It's unlimited. All I have to do is just keep, and everything I said was true, by the way. I didn't say a single false thing. Okay? So any two objects share an almost infinite and indefinitely large number of properties. So the issue becomes, you're not relying on a logical definition of similarity, because logically, any two things are extremely similar to each other. And that means similarity in that sense can help you categorize things. Because it's not going to pick one thing. Why should I put this with this? I should put it with this or any other object. This is what you actually do. You use psychological similarity. Psychological similarity says, out of all the logically shared properties, you're going to hate this, I only pay attention to some small subset that I consider relevant or important. Now, what you might be tempted to do is think you can give me some pre-specification of what those relevant properties are. Edible. No, we grouped lots of things together in which being edible isn't a property of them. Okay? Like, you have a category, shoes. It has nothing to do with whether or not you can eat it. And it doesn't prevent imminent death. Right? Well, it sort of, causes me to not have pain. So does your bed. Do you group shoes in your bed together? Well, no, and we can play this game. You're not going to be able to pre-specify what the relevant properties are. In fact, you will suddenly go from seeing a bunch of things as not belonging to a category as belonging to a category. You can have a snap. Barzilai did this. He called them ad hoc categories. Okay, so your spouse, your kids, your pets, important works of art, documents, explosive material, toxic material. Is that a category? Things you care about when there's a fire. Oh, right. That's a category. When there's a fire. So what's at the core of categorization? Your ability to zero in on relevant information and ignore a combinatorial explosion of logically possible information. Notice what I'm saying here. It's logical. Everything that I talked about between the plum and the lawnmower is logical because it has to do with truth. And here's what we're starting to see. And we knew this, and this goes back to Socrates. Truth and relevance aren't the same thing. Truth isn't fine-grained enough to get you to zero in on the relevance you need. So, what's another area in which we can see a convergence on relevance realization? By the way, if you're interested in this, there's a paper. There's two, Richards. This is from 2012, and then there's actually three. Okay. I'm not expecting you to read these for the course, but if you want to look at this in more detail and then also follow up on some of the sources we talk about. So, communication. Our ability to communicate is what allows us to tether our brains together and improve our power for dealing with the world. Communication is a central ability. But there's a central problem that faces you in communication. All right? And this has to do with the fact that you cannot actually transmit all of the information you want to communicate, because you have to rely on people making, right, connections, filling in missing pieces of information, right, reading between the lines. That is one etymology, by the way, of the word intelligence, interleisure, to read between the lines. So that's a pretty good one. Right. And now you're saying, well, what do I mean? Well, this has to do with the point that you have to convey more than you can say. So let me give you an exchange. Some of you have seen this before. That I hope doesn't strike you as that weird. You're standing on the street corner and somebody drives up, they put their window down, and they say, "Excuse me, I'm out of gas." And you say to them, "Oh, there's a gas station at the corner." And they go, "Thank you," and they drive away. Now, I don't think any of you would find that like, it's not like something, you know, from Waiting for Godot or something like that. It's not bizarre. But if you actually had to say everything you were communicating, it would go a little bit more like this. So you roll down when you say, "Excuse me," what you're saying, excuse me, and by that utterance, what I'm indicating is that someone near you wants your attention, and I'm going to take it that you're going to conclude that the person who wants your attention is actually the person who made that utterance. And I'm actually asking you to commit time and effort and attention towards me, right, in a way that is not going to be too demanding on you, immoral in any fashion, tax you too much unreasonably, and that you're going to be able to address me, face me, and communicate with me. I'm out of gas. And by I again mean the person speaking. And I hope you see that that person speaking is the same one that asked for your excuse, so that you would transfer your attention and continue to pay attention to me, and that you're going to continue to focus your attention on me. And when I say I'm out of gas, I don't mean me personally. I'm not requiring that you somehow help me to be more flatulent. I want you to conclude that what I mean is the vehicle that I'm in, and that conclude when I say I'm out of gas, that I actually mean the car is out of gasoline, and that I'm not talking about a gas, but actually gasoline, and that I'm not actually completely out of gas, because then of course I couldn't drive my vehicle to where I need to go to get more gas. But it's getting close, not too close, but close enough that you may be able to provide me relevant information that is closely matched to the amount of gas I need. Oh yes, I'm not going to address you. I'm not even going to address you as a person. I'm not going to try and learn your name. I'm not even going to say speaker who has spoken unto me. I'm just going to say out of the blue, oh yes, as a general acknowledgement that you will take as a specific acknowledgement that I'm going to pay attention to you right now. And that I have decided to agree with you, and that I have understood everything you meant about you being out of gas. And I'm not going to specifically say anything about your car, or you, or your needs, or how much. What I'm going to say matches that. I'm just going to say there is a gas station at the corner. And I'm going to assume that you understand that I understand that we're both using gas to mean gasoline. And corner means a relevantly close corner. It doesn't mean a corner in Mongolia. It means a corner that you can get to in your car. It means a corner that you can drive to, but not too far, because I've got the idea that you're not completely out of gas. You only need some gas. You've got some you can drive, right? And that you can get to that corner. And when I say there's a gas station at that corner, what I'm conveying is it's actually a place that sells gas. It's not just a museum gas station. It's not a little model. It's not a closed gas station that's no longer in business. And when you go there, you can get the kind of fuel for your car. It's not a gas station for Zeppelins, for example. And that they will exchange with you, right, gas for currency or credit backed up by the Canadian government. You won't have to offer anything else like your firstborn or anything like that to get the gas you need. And you know how I know all of those assumptions are in place? Because if any one of them is violated, you're pissed off. That's what you would have to say. And you know what's going to freak you out more? You know each one of those sentences I used to try and tell you what you had to say? Each one of them is conveying more than I say. So to actually take each one of those sentences, I'd have to also say everything that each one of those sentences is conveying. And then I'd have to say each one, and do you see what this is getting us into? But you don't do all of that. You just go, boop, zing. That's why another way we test people for intelligence is we test to see if they can follow a conversation, if they can answer questions, if they can communicate their ideas. Because this conveyance stuff involves zeroing in on relevant information. In fact, the guy who talked about all of this was a philosopher. Notice the philosophers again. See their role in cognitive science? It's not just the neuroscientists and the psychologists and the machine learners and the linguists, because we're doing language here too. We're doing language here. It's H.P. Grice. And Grice said, what you're doing when you're filling in all those missing pieces is, he said, sometimes you're drawing implications, but mostly you're drawing implicatures. You're trying to fill in the missing information, which isn't a strict deduction. You're doing an implicature. And you know the difference between an implication and an implicature. And you can see why most of the time you're doing implicature, not implication. If you're at a party and you ask someone and you say to someone, how many kids do you have? And they say, I have 2. And then later on in the party, you hear somebody, oh yes, I have to go home to my 4 children. And you go up to them and you say, what's wrong with you? I asked you how many kids you are, and you said 2. And the person says, well, if I have 4, that necessarily means I have 2. I did not lie to you. You think, what an asshole. You don't think, oh, I stand corrected by your logical validity. Because the implicature is that you're giving the most relevant amount of information at the time. And what Grice tried to do was figure out how implicatures work. And he thought there were 4 maxims, right? Quality, which basically says we assume, unless we have evidence to the contrary, that people are telling the truth. We'll come back to that. Quantity. People are going to give us the right amount of information. The problem at parties is people get drunk and they start to forget this. And they will often give you way too much information. Like you don't ask somebody, well I don't know, I'm very poor at parties, so maybe that's just because I get a very skewed representation. Often I ask people how they are at a party, and I don't drink, so I stay sober. A lot of parties aren't fun if you're sober. All right? So I stay sober, and I'll forget, and I'll ask somebody, how are you? And then they tell me how they are. And it goes on for an hour. Right? So sometimes we forget this, right? Right? There's the maxim of manner, which is like put it in the right format. Put it in a way that the other person can use. All right? And then finally, you'll love this, the maxim of relevance. Give the relevant information. Okay, so Sperber and Wilson came along and did work on this. They did work on it in a couple of papers, and then they did work on it in a book they call Relevance. And what they argued is that these two collapse into the last one. Manner just means use the relevant format, in our language, formulate it correctly, formulate it appropriately, give the relevant amount of information, not too much, too little. What about this one? Because this seems to be about truth. And what you should say is, John, you've told me that truth and relevance are the same thing. Yeah, you're right. And I think there is an expectation of truth, and I'll come back to that. But what Sperber and Wilson say is, most of the time, we're not demanding truth from people. What we're demanding is honesty. That's not the same thing. Somebody can honestly tell you something that turns out to be false. Okay? Some people talk about it a little bit differently, but I think it comes down to the same thing, sincerity. Okay, so what does it mean to say, and this is what does it mean to say that somebody is being honest or sincere? Well, it's that what they're putting into their words is what's in their mind. That's sort of the simple answer. The problem is that's You don't want that. Right? I don't want you to tell me everything that's going in your mind, even when I want more than a trivial answer from you. I say, well, what do you think about Donald Trump? Right? I expect a conversation with you. Right? But I don't want to know everything that's going on in your mind. I don't want to know that whenever you think of Donald Trump, you sort of have a small, faint image in the back of your mind of Donald Duck, because you just have that weird association, right? I don't want to know that while you're thinking about Donald Trump right now, your bowels are bothering you a little. I don't want to know, right, that you're having a vague, memory of a commercial jingle you just heard a few minutes ago as well. You got a bit of a slight headache, that your mind is, I don't want to know any of that. I don't even want to know everything you think about Donald Trump. I don't want to know that you think he looks like your Uncle George. What do I want? I just want the core, the crucial information in your mind that might be valuable to me. Another way of saying that is I want you to zero in on the relevant information about Donald Trump that's in your mind. So insofar as there's an aspect of it, they think it's all of this. I think that's wrong. I think they go too far. I think we do care about the truth. But I do think that a lot of the time we are caring about this, and when we are, it reduces to that. Which means, again, at the core of communication is the issue of relevance realization, because you're running on implicature. And implicature is not the same thing as implication and deduction. Again, do you see how we're doing cognitive science? We're looking at all these different disciplines. We're talking about psychology and linguistics, right? And machine learning will eventually start talking about some neuroscience. Right? And then philosophy is playing this important role, and we got these convergent from these different areas coming to this central idea. I'm going to do one more, because when I've done this in the past, and other people have done this issue in the past, right? What sometimes people say is, yeah, but I get that, sort of problem solving and communication and categorization, but you're just in the world and you have to get food and you have to avoid danger, and surely that's what you do. All right, well, a way to be really careful that you're not assuming the very thing you're trying to explain is to, again, and this is what cognitive science works on, it's called taking the design stance. How would you design a machine to solve the problem you're talking about? So I'm going to make a machine that's going to do a very basic thing. It's going to find an energy source, and then it's going to transport it to a safe location. Okay? Because that's what almost all organisms do, right? They will find their energy, food, and then they'll take it somewhere. Right? Even lions, well, the lions often can't move their prey, although a lot of the other larger cats do move their prey. Lions do a different thing. They surround their prey, and that's right. And we sometimes do that, but very rarely. Right? Imagine if we were like lions. You went into the supermarket, we just start eating the food there. Our friends would gather around us and protect us from the predators. I guess the people wanting money for the food. But generally, we're more like leopards and other creatures. We find our food and we take it somewhere. So what I'm going to do is I'm going to make a robot that's going to find a battery and transport the battery. That's all it's going to do. Very basic problem. A Darwinian survival problem. Okay? Now, I've got to give it a basic ability. I've got to make it a cognitive agent and not just a behavior. Okay? Everything behaves. But not everything is an agent. Remember, an agent is in some sense a capacity to direct your own actions. Right? So an agent is a thing that can determine the consequences of its behavior and adjust its behavior. So the chair, like a chair exhibits a lot of behavior. It does a lot of things. It's making a particular pattern of light right now. It resists, right? It's resisting, everything is behaving, right? But the chair isn't a cognitive agent because it isn't determining the consequences of its behavior and adjusting its behavior. So that's why one of the basic reasons right? Why we think intelligence requires agency, right? A mark of intelligent is being an agent. Okay, so what I'm going to do is I'm going to give the robot the ability to determine the consequences of its own behavior. Okay, so here's my robot. I'm going to give it some sensors. It's going to move around, right? And it's got this sort of army grabby thing. That turns out to be a really hard problem, but we'll put that aside for now. Getting a robot to do this reliably for different containers made out of different stuff, containing different weights of liquids, turns out to be really hard. So crush the can or fling the liquid, right? So that turned out to be, well, we'll put that all aside. Okay. So what I've got is I've got a wagon. And on the wagon is a nice juicy battery, which the robot wants. So beep, 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 ooh, ah. Basic perception. So what the robot determines is that if it pulls the wagon, it can move the battery. And remember, it wants to move the battery to a safe location. So it's going to pull the wagon, and that's going to have the consequence of moving the battery. And so it's going to pull the wagon. But there's a problem here. On the wagon is a lit bomb. Now, some of you may recognize this. This goes back to another philosopher, Daniel Dennett. So the problem is the robot pulls the wagon, the battery comes along, but the bomb also comes along, and the bomb goes off, which destroys the robot. And we find that perplexing. We say, oh, what did we do wrong? And then we realize, we made a mistake. We made a mistake. We only had the robot determining the intended consequences of its behavior, the intended effects. We didn't get the robot to check for unintended side effects. Unintended side effects. And one of the marks we have of people's intelligence failing, yes?
Would this be a good example of like a path constraint for the robot?
I don't, well, we'll see why it's not quite a path constraint in the way that I think you want it to be, in the sense of trying to put sort of, it's a kind of constraint, but it's not the same thing as you can specify it for a particular problem. But I see what you're doing. I wouldn't dig a philosophical trench and defend it to the end for it. Okay, so think about how we sometimes see intelligence failing when people do exactly that, when they only look at the intended effects and not at the unintended side effects. Reliably, unfortunately, tragically, every year, tens, sometimes hundreds of people die by doing the following thing. They go into a place where there is flammable gas and it is dark. And so in order to make light, what do? They light a match, which has the intended effect of making light. It has an unintended side effect, which is what? Igniting the gas and blowing them up and killing them. So not paying attention to unintended side effects is an important way in which you can be stupid. Okay? So we're very clever. We're very clever cognitive scientists, and we sort of and we pat ourselves on the back. We say, we're going to make the robot do better. We're going to make the robot not only look for the intended effects of its action, we're going to make the robot look for the unintended side effects of its action. Ha-ha! Now, that's going to take more processing power, so we put on some actual modules. Stuff like that. And then what we're going to do is we're going to put a black box inside the robot to see what it's doing, and we're going to put it back into this same situation, because this turns out to be a great test situation. And we put it, the robot goes up to the wagon, gets here, and does nothing, does nothing, does nothing, does nothing, and then the bomb goes up the robot. It's like, what? What's going on? So we take out the black box and we look, well, what was the robot doing? Well, the robot was doing what we asked it to do. It was determining not only the intended effect, right? The battery will come along, but unintended side effects, like that the left right wheel goes through more than 30 degrees of arc. So does the right front wheel. So does the back left wheel. So does the back right wheel. The grass underneath the wagon is being indented. The air patterns around the wagon are being slightly altered. The reflectance patterns coming off the wagon into the sensors are also being slightly changed, right? The battery is wobbling around, making a noise in the wagon. The position of the wagon with respect to Mars has been altered. How many unintended side effects are there? It's combinatorially explosive. So now, right, we think, oh, wow, I can't have it look at all of those, right? What I'm going to do, and I'm going to argue that the next part Dennett puts in here, we can't actually do the way Dennett says. I'm going to argue later we can't do the next move the way he says, but I'm going to give it to him just for the sake of the argument, okay? He says what we get is we get a relevance detector. I'm going to argue that there isn't such a thing. But I'm going to give it just for the purposes of continuing his example. So what we get is we get something that detects if a property is relevant. Beep, 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 beep. Okay? So now what we do is we put it in here and we think, okay, right? So here's the relevance detector. Right? Sorry, that makes him look kind of frightening, doesn't it? Okay, so we put them in here and we think, okay, now we're ready. Right? Okay, and we put it in here and the same thing happens. Nothing happens, the bomb blows up. What's going on? Right? Well, if we look inside the black box, the robot's made a list, right? Right? So we've got three things. We've got intended effects. And then of the side effects, we have relevant and irrelevant. And what it's doing is it's checking all the side effects. The wheels, left front wheel, irrelevant. Right front wheel, irrelevant. Back, irrelevant. Grass being indented, irrelevant. Battery making a noise, position. And it's checking all of these, detecting that they're irrelevant, and going, and it blows up. What we actually need the robot to do is to not even pay attention to these, but somehow find the ones that are relevant. So at the core of this, and I'm putting this in to remind you, that this is not quite the right way to think about it. And we'll see there's a deep reason about that in a minute. At the core of even this basic thing is the problem of relevance realization. Now I could do this a lot more. I could talk about memory, long-term working memory. I can talk about consciousness and how many people are now arguing that relevance realization is at the core of consciousness. I can make this an even more convergent argument, and believe me, I can. This is what my career is in cognitive science. But I'm going to take it that I've made it very plausible to you that many aspects of your cognition, and I'm suggesting to you also your consciousness and your experience, converge on relevance realization. Now, before I go on to talk about how that we might potentially, is the reason to believe that we might be able to give a naturalistic explanation of that, right, in terms of what the brain is doing. Before I do that, I want to stop and point out some important things about this relevance realization, because we've got to, I want to keep connecting it back to this idea of meaning. Look, relevance realization isn't a cold calculation. Relevance realization is how your brain is making the very risky decision as to what information it should pay attention to. What information it should commit its very precious attentional and processing resources. What information it should commit its very precious time to. Relevance catches your attention. It arouses your energy. It causes affective or emotional states in you. In fact, some people argue, myself included, that's the primary function of emotions. Emotions are designed to help you zero in on relevant information. What anger means is not to have particular thoughts, right? It's to find particular kinds of things salient or important, to focus your attention in certain ways, to be motivated in certain ways, to have your energy aroused or depressed in certain ways. That's what I mean by relevance. It is not some cold calculation. It is the lifeblood of your ongoing experience. It's what makes the world stand out to you. It's what makes things call your attention. It's what gets you emotionally involved. It's what makes you commit your metabolic resources so you are happy when you succeed and you are defeated when you fail. That's what I mean by relevance realization. That's what's going on here. That's what I'm talking about. It's not a cold calculation. It is the way in which you are sewn into the world so that you are involved with it. And it's constantly evolving. It's constantly shifting what you find salient and relevant. Most of it, right, is happening outside your awareness. You come into the room and your brain lays it out for you. You know how to move around, where to pay attention, how to orient yourself, how to treat objects, how to communicate what's going in your mind, how to understand. All of that's being laid out for you. And you're not aware of almost all of that processing. In fact, that processing exists before you as an ego do, because it starts working to make your memory work, to make your categorization work, to make your intelligence work, to allow you to learn, to allow you to communicate. It is what your ego grows out of. Your relevance realization is pre-egoic. It comes before you. It comes before the world that makes sense to you. I'm not talking about the world of physics. I'm talking about this. You can consciously intervene, but you can't make the world that is meaningful to you, that makes sense to you. Your actions presuppose it. Your ability to have a meaningful experience. If I take away relevance realization, you're going to be worse than the man who mistook his wife for a hat. No object will be categorized for you. You will not be able to communicate. You will not be able to solve problems. You will not even be able to pick up and move objects around like the robot. It's given to you. You think you learn from your experience. That's only after all kinds of relevance realization has happened so that you have a kind of experience from which learning and action are possible. Relevance realization is in that sense pre-experiential. Even though you experience it as the lifeblood of your existence, your lived existence, it is what makes your experience possible. Yes?
Is all relevance realization pre-egoic though? Because once I understand that...
No, not all. So what I mean by these terms, that's why I'm not saying it solely. I'm using the word pre in the sense that as you develop an ego, it can influence your relevance realization process, but it can't ever constitute them because it is dependent upon all kinds of processes that you do not have access to in order for it to exist. It's dependent upon the world being structured in a certain way, again, and you can't stand outside of that. The ego actually depends on all of those structures for its very existence. So although it can modify things, it can't be the ground of them. That's what I mean by pre. Is that okay? It's pre-rational. You have to have relevance realization before you can reason, because you have to be able to categorize things, you have to be able to set up problems, you have to be able to organize. Now, I'm not saying pre-logical, that's a different thing, pre-rational. It's pre-normative. Before you can make judgments if things are true, good, or beautiful, they have to fundamentally make sense to you. They have to fundamentally make sense to you. So pre-egoic, pre-experiential, pre-rational, pre-normative, pre-narrative. Before you can start to tell any stories, you have to be able to do relevance realization. It's before communication. So not only is it, right, not cold calculation, not only is it, right, this, right, very involving and evolving process of grabbing your attention, orienting you in the world, arousing your energy, affecting your motivation. It is also the ground out of which all of these other processes emerge. It is the way in which you are fundamentally bound to yourself, to other people, and to the world. I call this your fundamental framing. You and your experienced world co-emerge from this. I don't mean you as a physical organism. I mean you as an egoic, experiential, rational, norm-following, narrative, communicative being. You as anything like a cognitive agent that's ultimately a moral agent or a person, a social agent. What do I mean by framing? I think there are three things going on there. There's problem formulation, which I already talked about. And we talked a little bit about this, problem formatting. You have to set your problems up so that you can communicate them to other people in a relevant manner and communicate them to yourself in a relevant manner. So how you formulate your problems affects how you format them, and vice versa. You also have to find problems that you don't yet have. Because finding a problem before you get to it is way more adaptive than just waiting for it to occur. What you use is you use your problem formulation abilities to find problems, and you use your problem formatting. You're doing it right now. You're trying to anticipate problems, so you're using literacy. You're using your way of setting up problems to solve. You're doing that to try and anticipate problems you might have in the future. That set of interrelating processes of relevance realization, that's what I mean by framing. And what I'm pointing out to you is you have fundamental framing. This relevance realization is profound. You're immersed in it. So Costa, in one of his articles on this, he talks about it. It's like the atmosphere. He uses the analogy of like an atmosphere. Both that it protects you from, harmful radiation. This protects you from, right, harmful combinatorial explosion and ill-definedness. It also, like the air, makes possible your metabolism. It makes possible your cognitive agency. And like the atmosphere, it also distorts and alters how you see and experience things. It fundamentally frames your existence. Relevance realization is like a kind of atmosphere, I'm using this as an analogy, in which you live and move and have your being. And again, it's not a cold calculation. It goes to the very origin and sources of who and what you are in a way that grabs your attention, arouses your energy, and motivates your affect and emotion. That's why I think it has a lot to do with what we were talking about when we're talking about meaning. It has another aspect about it. Because one of the things I pointed out to you is that this relevance realization process, remember the 9-dot problem, the mutilated chessboard, you have to be able to reframe One of the things your relevance realization process can do is recursively turn back on itself and find its own, right? Relevance realization finds itself relevant. It finds its own processing relevant because it has to intervene. One of the things you have to be able to do as a relevance realization machine is break out of inappropriate framing. You have to be capable of insight. So this process also finds itself inherently relevant, inherently interesting. This is a fundamental way in which you care. Right? In that sort of, I've been using this notion from Heidegger, the way you sort of bound to things. And the way you are intrinsically interested in your own caring. Now, if we have psychotechnologies that could influence our relevance realization at a level below our narrative ego, then those psychotechnologies could have perhaps a huge impact on the very fundamental way in which we experience ourselves, our world, and how we're connected to ourselves, connected to our world, and connected to each other. Perhaps there are reframings that are very profound at a deeper level than the 9-dot problem or the mutilated chessboard. These would have to be very interesting psychotechnologies because they would have to be able to get at us at a lower level than we normally operate. What I'm going to suggest to you is that is exactly the feature of many spiritual exercises. They are psychotechnologies designed to alter relevance realization at a fundamental level, to create a kind of insight that is much more profound than something like the 9-dot problem or the mutilated chessboard. Not an insight into this problem or that problem, but an insight into, right, how you should live, the kind of thing that Varela is talking about. Do you see now why, by the way, in ethical know-how, why Varela is trying to talk at a certain level? He's trying to get you down to that level. I'm going to give you more of an argument shortly as to why he thinks that, why he's talking that way. Now, we face a difficulty here. So I'm going to go back and start talking about how we naturalize this, how we try to analyze, formalize, and mechanize relevance realization, and why it's problematic. But right now, and I don't have the right adjective, the impoverishment of language given our history is strangling at this point. The only word that comes to mind, and it is deeply misleading, is we're talking about, like as I said, spiritual exercises, things that bring about a spiritual transformation, which sounds like ghosts or something, which is not what I'm wanting to say. What I'm trying to use that word to do is to point to this level. Now here's the mistake that our culture made at one point. The Romantics, what was right about the Romantics, like in the 18th and early 19th century, is they were trying to point us to this level because we had forgotten about it. As science took over, as the Enlightenment took over, we had lost connection with this. As religion was dying, and we've already talked about that history, we were losing connection. So the Romantics tried to, right, point us towards this. And for that, great. What was wrong about it is that they thought our thinking about it, our theories about it, had to be this. Our theories couldn't be scientific, rational theories. And that's a fundamental mistake. Your theory doesn't have to have the properties of what it is a theory of. My theory of vagueness doesn't itself have to be vague. My theory of metaphor doesn't itself have to be terribly metaphorical. My theory of color doesn't itself have to be colored. I don't even know what that would mean. Your theory should have the properties of a good theory, not the properties of the thing it is theorizing about. And the Romantics made that mistake. What I want to say is we can have science, cognitive science about this, without deflating it, without making it go away in some Richard Dawkins fashion, right? But that doesn't mean that we have to become romantic about it. We have to say, well, we can't reason about it, and blah, blah. That's not. That's a fundamental mistake. Now, I happen to think that this gets us back, right, to an older idea that we've lost. We've talked about how the notion of faith used to be this sense of connectedness to the flow of things, a sense of the course of things, a sense of being involved so that you knew at a deep level which way to go. I think at one point, and we talked about this in the Hebrew idea, that's what faith meant. Now, faith has come to mean this notion, a largely decadent romantic notion. Faith means believing things irrationally. Right? But that might be a mistake. That might be a fundamental mistake. Because it might be that what people are trying to point to, or we're trying to point to with this term, and you can get a lot, like, even though, remember I told you this, even the word belief itself points to this rather than proposition. It comes from believe, right? To give your heart to something, to care about something deeply, to become deeply involved in something. Right? So, I'm trying to suggest to you, as we get a cognitive science of relevance realization, perhaps we can step out of this cul-de-sac we've gotten into when we're trying to think about meaning, spirituality, even words like faith. Now, I don't like to use that word because I think it has become deeply embedded, right, since Aquinas, in this idea of the willful assertion of things for which you don't have evidence. So, what am I trying to do? I'm trying to show you, I'm adding to, and I'm going to start adding to this more and more, that this construct is also elegant. It has the capacity, perhaps, to take us into areas where we thought we didn't have scientific discourse, find, formulate, and perhaps even start to solve problems that used to be considered outside of science. That would be to show that this notion of relevance realization is elegant, and particularly elegant about the concerns of this course. Concerns about meaning, the sense of connection, the capacity for self-transcendence, the capacity for overcoming self-deception. Notions about spirituality and wisdom. How psychotechnologies may alter us in a fundamental way. How we may get a sense, again, of what enlightenment means, because it might not mean changing you at this level, sort of changing you at the normal level, but changing you at this level. That's why you're sitting through this somewhat dry lectures about combinatorial explosion and robots and batteries, and like, it's like, I want to see Buddhas. And I want to hear about weird, trippy experiences. Okay? But what if, instead of just romantically leaping into that and wallowing in sort of vague descriptions and metaphorical ejaculations about this, why not, what if we could talk about all that stuff scientifically? Not explain it away, but actually talk about it. Investigate it. That's worth the effort. And that's why I'm asking you to make this effort. It's worth that effort right now. Okay. So, now back to it. So what I'm doing right now, as you can probably see, is I'm moving between sort of cognitive science of relevance realization, and then how it can have an impact on Buddhism and the meaning crisis. Right? Going back and forth. Let's go back now to the cog-sci. And we're not going to finish the cognitive science of relevance realization today. We're going to do some more on it. And then what will happen on Wednesday is we're going to do more of that, right, elegance. We're going to start applying this notion more and more to work out, right, what we mean by meaning and what we could mean by wisdom and what we perhaps could even mean by enlightenment. Yes, towards the end of the course, I'm going to do the most audacious things. I'm going to try and offer you a cognitive scientific theory of enlightenment. Now, the romantic in you is probably screaming, saying, don't take my magic away. You should always give up magic if it's going to give you wisdom. That's one thing that all the wisdom traditions say. One of the most consistent messages they give is, give up magic for wisdom. Okay, now let's go back to it. So how would we go about trying to do a theory of relevance realization? Well, one thing to do is to try and find the kind of mental stuff it might be made out of. I mean, that's what you do. That's what Thales did. You try to find the fundamental stuff and the fundamental forces. Okay? So one thing, the level at which you might think you could work or come up with a theory of relevance realization might be the representational level. The level at which you use representations. Right? And this is the level at which your beliefs operate. You have beliefs about this or that. You have commitments to certain representations. It's most of your conscious everyday experience is a very one built on representations. You're using language and pictures, and you have beliefs about things, and it's all that representational level. Right? But this is going to turn out to be, right, the wrong level to look for relevance realization. You can't find relevance realization here. Not because relevance realization isn't at work. That's not what I meant when I said you can't find it here. What I meant is you can't find the basis for it here. Representations can alter what we find relevant, but they can't be the ultimate source of relevance realization. Why not? Well, because of the way in which representations actually work. So it's very hard for you, in fact, to engage with this without probably having a representation of it. So like it's a bottle and things like that. Okay? Now this is something that John Searle pointed out. He's a philosopher. He pointed out in connection with consciousness. Some of you who've done work with me on consciousness know I think he's got this argument the wrong way around, but I'll leave that aside. What Searle pointed out is you have to do a lot of work to generate a representation of an object. Okay, so try again. Now that I've done some of the lectures, you should be able to answer some of these questions. How many properties does this actually possess? How many true things can you say about it, do you think? How many? 5? 7? 22? How many? Come on, somebody.
Infinite,
Not maybe infinite, but at least indefinitely large. Because Chomsky thinks that there's not an infinite number of sentences you can utter. So let's say he's right. I don't know. Okay. So you can't, when you're trying to represent something, you don't grasp all of its properties. Okay? So I'm a martial artist, so is he, by the way. I know how to use this to kill you. Now, for most of you, those properties are probably not salient in your mind right now. I have a friend, well, he's one of my best friends, and he's a co-author with me, Leo Ferraro, and he's like Batman. Whenever he meets anybody, It's like in Jason Bourne. There's that one scene in Jason Bourne, where he says, well, that guy at the bar, that's like Leo. He just knows that guy can fight, that guy can't fight. Okay, if I fight this guy, I'm not going to use Wang Chung. I'm going to, like, he just reads people. You probably don't do that, right? But all those properties are there. Now, you probably do it. You probably can assess people by how they're standing. I know I do when I'm watching somebody stand, right? He's carrying all of his weight on his right foot. Look at that. Look at it, right? Look at it. He cocks his hip a little bit to the left. So, you know, blah, 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 all that stuff, right? Well, now, what am I trying to get at? I'm not trying to scare you. I promise. I'm not going to hurt you, right? What I'm trying to point out to you is that of all of the properties that an object has, guess what you do? You only zero in on some very small subset that you, listen to my language, care about, that's important to you. And not only do you do that, do you remember the example of the bird? Remember feathers, wings, flies? Do you remember that? What was missing? What was missing there? Do you remember? Remember the gestalt? The functional organizational structure? Not only do you have to pick out the features, you organize them into how they are relevant to each other and relevant to you. You do that logos thing. And remember, you can't even really put into words what that logos is, what that gestalt is. But it actually makes the bottle stand out for you as a bottle. So that if you need to carry a liquid, this becomes salient to you. And you start to look for things that look like this, that have the right bottle shape. So what do? You use relevance realization to zero in on the properties you care about. You use relevant realization to organize them so they fit together, belong together. And you use relevance realization to make that matter to you. So what are you using to generate representations? What process? Relevance realization. That's what I meant when I said relevance realization is pre-representational. Not that representations don't use it, not that representations can't transform it, but ultimately you can't use representations to generate relevance realization, because representations rely on relevance realization. Relevance realization is more basic than representation. You need relevance realization in order to make representations. So you can't ultimately make relevance realization out of representations. Now you're perhaps getting a deeper sense of what I mean when I say relevance realization isn't ultimately about belief. It's not about things that are in representational states in your mind. That's why Varela is talking about coping. He's trying to get you to drop below the level of representation, below the level of belief. That's why he's talking about ethical know-how. So, does that mean then that our fixation on words and beliefs is misleading fundamentally what people have been trying to work with when they have been trying to cultivate wisdom and compassion and meaning and their spirituality? Perhaps. Other people have argued so. Karen Armstrong, in a book called The Case for God, makes a very similar argument. She doesn't make it from cog-sci. She makes a historical argument that when people in the past were talking about this, they weren't primarily talking about belief. They weren't primarily talking about propositions to be asserted. Another excellent book, and he came here, by the way, for the UTism in 2000, bless you, UTism of 2014, John Karse. He has a book entitled, and perhaps you'll now see why this is not an oxymoron, The Religious Case Against Belief, where he's primarily arguing that the idea that religion is primarily a system of belief is a mistake, a fundamental mistake. Think about this word. There's a couple of etymologies to it. The one that most people think it comes from is, and I'm going to use this word later in the course, is the Latin word religio. Now, that's not this word, credo. Credo is, I believe. That's where we get creed from. All creeds, right? What does religio actually mean? It means to bind things together, to make connections, to have things belong or fit together. In fact, I'm going to make a very good, I think a very good argument. Sorry, that sounded self-promotional. I think the argument is very good that a better way of understanding religio is in terms of relevance realization, how we are bound to things, how things fit together, how they belong together for us. That's it for today. We will continue on with trying to get at the cognitive science of relevance realization, whether or not the computational level is the right level, and so on. And along the way, we will talk more about the spiritual, for lack of a better adjective, significance of relevance realization.